Hey everyone, my name is Shashank, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for JEE Ans 2018, Paper 1. The question taken in this video is from the chapter Probability, as in the paper. It's a very good problem and this was asked under section paragraph. So there are two problems. We will see both the problems one by one. See, it says the common paragraph for both the problems is there are 5 students S1, S2, S3, S4, S5 in a music class, and for them there are 5 seats R1, R2, R3, R4, R5 arranged in a row, where initially the seat Ri is allotted to the student SI, I is equal to 1, 2, 3, 4, 5, but on the examination day the 5 students are randomly allotted the 5 seats. Means originally the seat of S1 is R1, S2 is R2, R3 was allotted to S3, R4 allotted to S4 and R5 allotted to S5. But on the examination day, they sit randomly to these places. Now the first question in this paragraph is the probability that on the examination day, the student S1 gets the previously allotted seat R1, means S1 goes to its own place. We have to find the probability of it, and also of this event that none of the remaining students get the seat previously allotted to him oblique her is. Means we have to find the probability that S1 goes to its own place, but none of S2, S3, S4, S5 go to their original seats, respectively R2, R3, R4, R5. So this is a clear-cut problem of derangement of 4 things, not of 5 things, because S1 takes its original place now. So there is only one choice for S1, that is R1, and for remaining 4 we have to derange 4 things. So let's see how can we solve it. So options given here is 3 by 40, 1 by 8, 7 by 40 and 1 by 5, right? Let's see which option is correct. Okay, so total number of cases would definitely be 5 factorial, and that is 120. Now see the favorable number of cases for this. S1 goes to R1 and remaining S2, S3, S4, nobody is going to its original place. So the favorable number of cases would be like S1 goes to R1, means there is only one choice for S1, and for remaining 4 derangement of 4 things, and D4. And what is value of D4? D4 is basically, there is a formula for Dn now. D4 is 4 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. So it is nothing but 24 into 1 by 2 minus 1 by 6 plus 1 by 24, that is 12 minus 4 plus 1, and that is 9. So the answer required probability must be equal to favorable, that is 9, total was 120, so it must be 3 upon 40. So 3 upon 40 should be the final answer to this question. Okay, so the first option is correct, 3 upon 40. Now coming to the second one. However, D4 we should know D4 value is very common to know. D4 is 9, D5 is 44. These are common values of DNs. Now coming to the second problem with the same common paragraph, Ri allotted to SI for every I 1, 2, 3, 4, 5. So they are asking about, now the question number 18, for I equal to 1, 2, 3, 4, let Ti denote the event that the student SI and SI plus 1, means S1 and S2, similarly S2 and S3, S3 and S4 and S4 and S5. So Ti's are defined. Do not sit adjacent to each other on the day of examination. Okay. Then the probability of the event T1 intersection T2 intersection T3 intersection T4, means S1 S2 should not sit together adjacent to each other. Neither S1 S2 nor S2 S3 nor S3 S4 nor S4 S5. So however, this question can be solved using the idea of principle of inclusion exclusion, using the formula of principle of inclusion exclusion, but again it is lengthy using that formula. It's quite lengthy. The better way to solve this question is by making cases. If you gives little stage to the mind, if you fill the cases by making cases by first taking the middlemost position taken by which of the students, then it will be easier. So middlemost, again total number of cases here is, first see total number of cases. Total number of cases is again 5 factorial, that is 120. Favorable number of cases I am writing on the next page. Okay, so favorable number of cases. In May, I am making first case when the middlemost position is occupied by, say I am starting with 3, because if middlemost position is occupied by 1 or 5, the number of cases will be same, or 2 or 4, number of cases will be same due to symmetry of the structure. So I am starting with taking 3 here, the cases will be very less. If the middlemost position is occupied by the student number 3, that is I am writing 3 means S3. So its neighbors must not be 1 or 2 or 4. So neighboring numbers can be 1 or 5, right? So here you can take 1. If you take 1 here, like 1, 3 k round 1 and 5 here, so we have only single choice for placing student number 2 and 4. 2 should come here and 4 should come here, and there will be a flipping of this structure around 3, middlemost number k round. We can flip it, so I can write 2 5 here and 1 4 here. So there will be 2 cases, full cases. There will be no other cases when 3 is the middlemost number. Similarly, when you fill it taking middlemost number as say 1 or 4, so I am taking 1 first, middlemost number as 1, so we can take its middlemost number as 2 first. Okay, I am taking 2 first, then we will see when it is 1. When middlemost number is 2, it is again not difficult to count the number of cases. We can easily write them here. So middlemost number is 2, so neighboring numbers must not be 1 or 3, so it must be 1 or 3. Okay, so neighboring numbers can be 4 or 5. So if you take 4 here, 5 here, then there is only one choice for remaining 2 places. Besides 4 should 3 should not come, so here 1 will come and here 3 will come, and it's flipping and it's flipping around 2, around middle number, means I'm clearly saying that 2 5 here, 4 here, then 1 here, 3 here, right? So again we have 2 cases here, right? And similarly, if you take middlemost number as 4, same will be the number of cases as we have counted when the middlemost number is 2. Due to the symmetry of the structure, again you can easily count it. So 2 cases here. Now we are left with the remaining 2 cases when the middlemost number. Cases are made on the basis of what the middle number is, middlemost number is. So when middlemost number is 3, first case number 1, case number 2 middlemost number is 2, case number 3 middlemost number is 4, similar as above. Right, when minimum number is okay 1, what would happen? See, when minimum number is 1, the neighboring numbers of 1 should not be 2, any of the neighboring number. So we can have 3, 4, 5 as its neighbors. When I take 3 here and 4 here, so we are left with 5 and 2. 5 cannot come here, so I will write 2 here and 5 here, and it's flipping. So into 2 I am doing, right? This is due to the count of flipping. You can flip it. And again, when middlemost number is 1, but its neighboring numbers are not 3 and 4, but 3 and 4 and 5. 4 and 5. Then here we are left with I think 1, 4, 5, 2 and 3. 2 and 3. 3 cannot come here, so we should write 3 here only and 2 here only, and it's flipping, so into 2. And when I write 1 in the middle number, 1 as middle number, but S1 is at the middle place, middlemost place, but here 3 and 5 is, I am writing 1 here, 3 here and 5 here. Then you will find there will be no choice for placing student number 2, because student number 4, because student number 4 cannot come here, because it should not come adjacent to 3, or here it should not come adjacent to 5. 4 should not come adjacent to 3 or 5 now. So this arrangement is not possible. So there will be finally 4 cases when middlemost number is 4 cases, and same will be the case when middlemost number is right, middlemost number is 5. So I am taking middlemost number as 5. Then there will be again same as above, same as above, similar as above. So here again you will get total number of cases as 4 cases. So how many cases are total? We can count it. 4 plus 4 plus 2, 4 plus 4, 8 plus 2 is 10, plus 2, 12, plus 2, 14 cases are there. Total number of, favorable number of cases is 14 cases. So the answer to the question must be final answer required probability. Probability must be the favorable upon total, that was 120. The final answer to this question must be 7 upon 60. Right? I hope you understood it. So it was easy to make cases to for solving this question, because again if you go for principle of inclusion, however you can do that, again the problem the number of situation, number of considerations are higher in that manner. So this is better. The question was, I would say, at a very higher level. So the final answer to this question is 7 by 60. You can see option C is correct here. I hope you understood this solution, the entire paragraph, student. Thank you so much.